Okay, we're continuing lesson 16. We're actually dealing with rational graphs. We're actually dealing with rational graphs. And remember, the parent function would be like y equal 2 over, or excuse me, y equal 1 over x. Now, that's the parent function. If we thought about adding something to the end, what's that going to do? Is that a vertical or horizontal shift? It would cause it to do what? Shift up 1. So my line of symmetry, my asymptote, my whole thing is going to shift from the horizontal line, y equals 0, up 1 to the horizontal line, y equals 1, correct? So just seeing the plus 1 added to the parent function tells me that there will be a vertical shift of 1, and so my asymptote would go from being the x-axis, which is the horizontal line y equals 0, to the horizontal line y equals 1. Now, there's a understood parenthesis situation here, and what I have is a minus 0. When you take a look at that, that means there's no vertical shift, okay? That means there's no horizontal shift, excuse me. And so the vertical asymptote is still 0. And this is the vertical line, x equals 0. So there was no horizontal shift, therefore my vertical asymptote is it still x equals 0. There was a vertical shift of up 1, therefore my horizontal asymptote went from the x-axis, which is y equals 0, up 1 to y equals 1. So I know that my little curves are going to be in quadrant 1 and 3, and they're going to be in there. Now, let's talk about that 2. See, the 1 in the parent function just got changed to a 2. What if we had a line y equal x, and we changed it from y equal x to y equal 2x? What would have happened to the graph? It would have gotten steeper. What if we had gone from y equal x squared, the parent function of a quadratic, to y equal 2x squared? Well, the wings would have gotten steeper, so the parabola would have gotten narrower. What's going to actually happen on a y equal 1 over x, y equal 1 over x? If you have these little curves in here, if you make that a 2 over x, it's going to pull away from the origin, okay? The little curve is going to be further from the origin than it used to be from the origin. That's what the 2 is going to do. We'll find that out as we pick some points and graph. But you may have wondered when you looked at that, what's that 2 going to do? It's not a horizontal or vertical shift. It's a stretch away from the origin, okay? Just like our wings folded in, or it got steeper, it changed the steepness of that curve, or the quickness of that curve, okay? Okay, let's take some of that out then. Now, again, if we're going to get a nice little table of points for that much curving, we've got to have several points. And to build a table, we start with x because it is the domain or the independent variable, and we solve for y because it's the range or the dependent variable. And what we put in the middle is what y is equal to. And what we could do is just choose the old faithful -2, -1, now 0, 1, and 2. And just kind of see what happens. You might think about the fact, though, that if we're dividing a 2 by something, if we have something bigger than 2, it's going to turn into a fraction. So this is going to give us some whole numbers to start with, and we'll see where we're at and then think about what we need to choose next. So we're going to have 2 divide negative 2 plus 1, 2 divide negative 1 plus 1, 2 divide 0 plus 1, 2 divide 1 plus 1, and 2 divide 2 plus 1. Now on the first one, we're going to get negative 1 plus 1 is 0. And then we'd get negative 2 plus 1 is negative 1. Division by 0 is mathematically undefined, and so there we must have hit an asymptote. Okay? Then we get a 2 plus 1 is 3, and a 1 plus 1 is 2. Now let's go ahead and plot those points. We're going to have the point negative 2, 0, which is down here. I'm off a little bit there. Let me try to get that out. Sorry. It's going to be challenging. We have the point negative 1, negative 1. We have the point 0 undefined, which is the asymptote when x equals 0. We're sitting on that green line. So it's undefined there, which we knew. 1, 3 would be to the right 1 up 1, 2, 3. So we're sitting right in there. And then 2, 2 would put us right here. All right. So we kind of ended up in about the same spot. So we got the bend a little bit. You can see the bend did pull away from the origin just a little bit. So we can pick some bigger numbers if we want to see where they end up. So we could try 4 and negative 4, and then we should probably try some fractions, correct? When you have a rational graph, you need to get some fractions. So let's try a negative 4 and a positive 4. But then let's also choose negative 1/2 and positive 1/2, negative 1/4 and positive 1/4. And that ought to give us some more nice little points. If that doesn't do us enough good, we will try some more points, okay? So we're going to have 2 divide negative 4 plus 1, 2 divide 4 plus 1, 2 divide negative 1/2 plus 1, 2 divide 1/2 plus 1, 2 divide negative 1/4 plus 1, 2 divide 1/4 plus 1. Now negative 2/4 is negative 1/2 plus 1 is positive 1/2. 2/4 is 1/2 plus 1 is 1 1/2. If I divide by negative 1/2, it's like multiplying by negative 2, and 2 times negative 2 is negative 4 plus 1 is negative 3. 2 divide negative 2 is 4 plus 1 is 5. 2 divide negative 1/4 is negative 8 plus 1 is negative 7. 2 divide 1/4 is 8 plus 1 is 9. When you divide by a fraction, you multiply by the reciprocal, as we know. And we're throwing in our sign rules and all that good stuff. Any questions on that? So there's a lot of good math that pops in here with multiplying by the reciprocal, sign rules. The first one was negative 4 1/2. So we are at negative 1, 2, 3, 4, up 1/2. Let me find it again. 1, 2, 3, 4, up 1, up 1. Negative 4, negative 1/2. Oh, there's my. Oh, I'm up 1/2. I see where I'm at. I got lost. 1, 2, 3, 4, up 1/2. So we're. I can't get in there. We're right there. There we go. Okay. And then 4, 1 1/2, positive 4. To the right, 1, 2, 3, 4, up 1.5 puts me, if I can find the spot, right in there. So those were good choices. We got closer to some asymptotes there. Negative 1/2 and negative 3. Negative 1/2, negative 1, 2, 3. That was a good choice. It put us closer to the asymptote on this side. Positive 1/2 and positive 5. Positive 1/2 up 1, 2, 3, 4, 5. Again, that put us a little closer to that asymptote on that side. That's really enough. I mean, we've got our turn. We're close to each asymptote. The negative 7 and the 9 would just even get us closer. That's probably enough points, though, to know that our curve is going to do something like this and something like this. And you can plot those other two. That wasn't supposed to hit the blue line. It was supposed to get ever so close to it without touching. Okay? Okay. The time was still going, though. Okay, we got it. All right. Thank you, though. We thought we lost our recording. Any questions on number 4? All right. Cool. Everybody see all that? All right. Number 5. We're throwing all kinds of stuff at you. We've thrown in some linear. We're going to throw in some quadratic. We've got the rational, which is what this lesson is. We're throwing in some absolute value. What is number 5, y equals 6? It's a horizontal line. There's no asymptotes. When you build a table, you do not need a middle section because y is not dependent on x. Y is constantly 6. Remember that from long ago? An equation with y only is a horizontal line. The slope is 0. The y-intercept is the constant y value 6. To build a table, we do not need a middle section because y is not dependent on x. Y is constantly 6. We're going to have a horizontal line through y's 1, 2, 3, 4, 5, 6. And that's all there is to it. Any questions on number 5? If it was x only, it would be a vertical line. The slope of all vertical lines is undefined. For y-intercept, we put none because it doesn't have one. It is parallel to the y-axis. Any questions on number 5? Okay. Number 6. Number 6, what's outside the parenthesis happens to y in the order of operations. So y will decrease by 3, which means that it's going to do what? Shift down 3. Now, if it shifts down 3, and don't draw this, but we had a horizontal asymptote here, which is y equals 0, right? If it shifts down 3, it makes the horizontal asymptote here. And we do want to draw the second one. So that means we're going to have a horizontal asymptote at y equal negative 3. We shifted down 3. So it moved our horizontal asymptote. which is now y equal 3. What's inside happens to x in the inverse order of operations. You would undo subtraction by addition. So what's really happening to x is a minus 1, which means that we would shift left 1. The vertical, don't draw this one, the vertical asymptote was here. But we're going to shift left 1. So we're going to draw the second one, which puts our vertical asymptote here at x equal negative 1, that vertical line. Understand that? In the parent function, your asymptotes are your x and y axis. We shifted down 3 from the x-axis, which puts us at y equal negative 3. We shifted left 1 of the y-axis, which puts us at x equal negative 1. So my vertical asymptote is x equal negative 1, and my horizontal asymptote is y equal negative 3. So we know our curves are going to bend in quadrants 1 and 3 there, unless that 1 up there was negative, and then it would do some reflecting. But it's still positive, so we're still going to end up in quadrant 1 and 3. So we're going to build a table of x, y values. We start with x because it's the domain or the independent variable. We solve for y because it is the range or the dependent variable. And we're just going to start with the old faithful numbers and see where we land and see what to do from there. So we will begin with the old faithful negative 2, negative 1, 0, 1, 2. So we're going to have 1 over negative 2 plus 1 minus 3. 1 over negative 2, negative 1 plus 1, negative 1 plus 1 minus 3. 1 over 0 plus 1 minus 3. 1 over 1 minus 1 minus 1 plus 1 minus 3. 1 over 2 plus 1 minus 3. I'm getting confused on which one was plugging in, which one was changing. All right. 1 over 2 plus 1, negative 2 plus 1 is a negative 1. 1 over negative 1 is negative 1. Negative 1 minus 3 is negative 4. 1 over 1 plus 1, negative 1 plus 1 is 0. Division by 0 is mathematically undefined, so we must be at an asymptote. That x equal negative 1, green one. We just hit the green one. So it got kicked out. On the next one, we've got 0 on the 1 on the bottom. 1 over 1 is 1 minus 3 is negative 2. On the next one, 1 plus 1 on the bottom is 2, so we have a half minus 3 is negative 2 and a half. On the next one, we've got 1 over 3 is a third. Negative 3 plus a third is negative 2 and 2/3. We just took a third off of negative 3. We can plot and see where they're at and then decide what to choose from there. So we've got the point negative 2, negative 4. Go back up here and find my origin. Negative 2, negative 1, 2, 3, 4 puts me right in there. Negative 1, negative 3. Negative 1 undefined, excuse me. I was going to say that can't work. It's on an asymptote. We can't have a negative 1, negative 3. Okay. 0, negative 2. To the left or right, 0. Down 2 puts me there. Two, I'm getting mixed up. One negative 2.5. Thank you. So I've got to the right 1, down 1, 2.5. Wow. I'll hit it in a minute. Right inside there, right above that blue line. 2, negative 2 and 2/3, which is even closer to the blue line. So we're hugging the blue line. Most of those ended up on the top side. All right. So we need to choose some more points. What would you like to try? Negative 4, negative 3, maybe negative 1/2, negative 1/4, maybe a positive 1/4, a positive 1/2. Try some fractions. So we're going to have 1 over negative 4 plus 1 minus 3. 1 over negative 3 plus 1 minus 3. 1 over negative 1/2 plus 1 minus 3. 1 over 1/4 plus 1 minus 3. 1 over, that was a negative, positive 1/4 plus 1 minus 3. 1 over 1/2 plus 1 minus 3. See what happens with those. So we have negative 4 plus 1 is negative 3. So we have negative 1/3 minus 3 is negative 3 and 1/3. There's a 1 in that tail of that y. Negative 2 plus 1, negative 3 plus 1 is negative 2. So we have negative 1/2 minus 3 is negative 3 and 1/2. We have negative 1/2 here. Negative 1/2 plus 1 is 1/2. 1 divided by half is 2, and 2 minus 3 is negative 1. On the next one, we have 1/4 plus 1 is 5/4. 1 divided by 5/4 is 4/5. 4/5 under negative 3, or over negative 3, is negative 2 and 1/5. 1/4 plus 1 is 1 1/4. Ooh, I messed up on that one. I added instead of subtracted. Forget I said that. That had a negative 1/4. Excuse me. Negative 1/4 plus 1 is 3/4. The reciprocal of 3/4 is 4/3, which is 1 1/3. You take 1 1/3 off of negative 3, and you've got negative 1 2/3. There you have it. 1/4 plus 1 is 5/4. The reciprocal is 4/5. 4/5 above negative 3 would be negative 2 and 1/5. 1/2 plus 1 is 3/2. The reciprocal is 2/3. 2/3 above negative 3 is negative 2 and 1/3. All right. A lot of fraction stuff going on there. Punch it in the calculator if you have to, but you really ought to be able to do the math. All right. So we've got negative 4, negative 3 1/3, negative 4, 1, 2, 3, 4, and negative 3 1/3, negative 1, 2, 3 1/3, and so we're hugging that asymptote there. That's good. Negative 3, negative 3 1/2, negative 1. I missed that. That should have been here. It's all gone. Anyway, so we had an asymptote at x equal negative 1. We had an asymptote at y equal negative 3. So we had this asymptote. We had this asymptote. And we had some points going off in there, so we ended up with a graph here and here. And you can finish that out. That's got kind of ugly there. But anyway, we got the point. All right? We were getting enough points to get there, and you can finish that out. Any questions on that? So the concept here, when it's rational, you just have to try a bunch of points. You just can't do it easy. You just have to crunch through all that, okay? All right. Number 7. Number 7 is a what kind of a graph? Exponential. It's an exponential graph, okay? The graph of an exponential looks like this, okay? It's going to do something like that. Now, we're not really going to talk about asymptotes here. It really does dead end. It kind of approaches, we're going to see this happen. Let's just go ahead and start building a table and see what happens. To build a table, we start with x because it's the domain or the independent variable. We solve for y because it's the range of the dependent variable. Let's just go ahead and make this fun and put -3, -2, -1, 0, 1, 2, 3, and see what happens to this. That'll help us understand our exponential law better. So we're going to have 2 raised to the -3 minus 4, 2 raised to the -2 minus 4, 2 raised to the -1 minus 4, 2 raised to the 0 minus 4, 2 raised to the 1 minus 4, etc. And we have to know our basic laws of exponents. What does the negative on the exponent say? It's a command. It says what? It says the reciprocal of. That's what it says. The negative on the exponent says the reciprocal of. So that first part says the reciprocal of 2 cubed. What's 2 cubed? What's 2 cubed? 2 times 2 times 2, 8. But we don't want 2 cubed. We want the reciprocal of 2 cubed. What's the reciprocal of 8? An eighth. So 2 to the -3 is 1/8. It is the reciprocal of 2 cubed. Now what's 1/8 minus 4? -3 and 7/8. You take an eighth off, right? Okay? Understand that? So what's 2 to the -2? It is the reciprocal of 2 squared. 1/4. What's a fourth off of -4? -3 and 3/4. Right? What's 2 to the -1? It's the reciprocal of 2. What's the reciprocal of 2? A half. What's a half off of -4? -3 and a half. Or I should say a half above -4, if you think about the number line. What's anything to the 0 power? Not 0. 1. 2 to the 0 is 1, and 1 minus 4 is -3. Anything to the first power gives you that number. So 2 to the first is 2 minus 4 is -2. 2 squared is 4 minus 4 is 0. 2 cubed is 8 minus 4 is 4. So there's some exponential law. The negative reciprocates it. Anything to the 0 power is 1. Anything to the first power is that number. Half power means square root. Third power means cube root, etc. So we've got -3, -1, 2, 3, and 7/8. We've got negative 2, negative 3 and 3/4. Negative 2, negative 3 and 3/4. It's up just a hair higher. Negative 1, negative 3.5. Negative 1 is at negative 1, 2, 3.5, just a hair higher. It's creeping up. 0, negative 3. 1, negative 2. Now it's not creeping up, it's jumping up. 2, 0. Now it's really jumping up. See the exponential growth? It's growing exponentially. The change in y, change in x is exploding. Okay? And then the next is 3, 4 to the right, 3 up, 1, 2, 3, 4, and we can see that it really took off. So you can see what's happening here is it's not really going back up there. It's approaching that line. It does kind of have a horizontal asymptote down there. But we don't really call it that. It's just a situation. It's approaching it. I guess you could call it an asymptote, but we're not dealing with rational there. Any questions on number 7? Okay. Exponential graph. Exponential graph. I think that's page 187 of the Algebra 1 book. Okay. Number 8 is an absolute value. Absolute value. I forget what page of the Algebra 1 book that is. It's like not coming in my head. Chapter 10. It's in chapter 10 of the Algebra book. Page 234. Somebody want to look that up? Somebody look that up for me. Chapter 10, absolute value graphs. It's getting down in there pretty good. All right. Now, we're not gonna talk about asymptotes. We're going to build a table of x, y values. What y is equal to goes in the middle, negative 2, absolute value x plus 1. Remember, absolute value represents distance. There's no such thing as a negative distance. Therefore, absolute value is always positive. Now, so graphing absolute value equations would be page 265. So page 265 is where this is in the Algebra 1 book. Thank you. Chapter 10. Now, we're going to build a table of values, so let's just go negative 2, negative 1, 0, 1, and 2, and see what that does for us. So we're going to have negative 2, absolute value, negative 2 plus 1. Negative 2, absolute value, negative 1 plus 1. Negative 2, absolute value, 0 plus 1. Negative 2, absolute value, 1 plus 1. Negative 2, absolute value, 2 plus 1. What does the parent function, y equal absolute value x, look like? What does it do? It looks like the parent function of a line, except the part that would have gone into quadrant 3 goes back up into quadrant 2, because absolute value will not allow those negative y's, correct? So it's the parent function of a line where the piece in quadrant 3 ended up in quadrant 2. So it turns into a V. All right. So absolute value negative 2 is 2. 2 times negative 2 is negative 4. Negative 4 plus 1 is 3. Absolute value negative 1 is 1. Times negative 2 is negative 2. Negative 2 plus 1 is negative 1. Absolute value 0. A 0 times negative 2 is 0 plus 1 is 1. Absolute value 1 is 1 times negative 2 is negative 2 plus 1 is negative 1. Absolute value 2 is 2 times negative 2 is negative 4 plus 1 is negative 3. That gave us some pretty little reflecting points, so that ought to make a nice looking little V shape. So we're going to have negative 2, positive 3. We're going to have negative 1. That's negative 2, negative 3. Thank you. We had negative 2, negative 3. We had negative 1, negative 1. We had 0, positive 1. We had 1, negative 1. And we had 2, negative 3. Let's talk about what each of those numbers should make happen. What should that plus 1 make happen that got added to the parent function? It made it shift up 1, correct? What did that 2 do? It made the wings steeper. You see, that 2 is like in the slope position, and that would make the line steeper, which made both wings steeper. And then the negative caused it to reflect down and face down instead of face up, okay? So we should also know what each number in there caused to happen. Any questions on number 8? Okay? And that's it. All right. Appreciate your attention.